Good morning. This is the video for AP Stats for the second half of section 5.2. This is the rest of section 5.2. So we're done with this section after this video. And the topics here are listed. We're talking about two-way tables and probability. That will not be new to you. Little notation might be new. Talk about Venn diagrams and probability. And again, I know you've seen Venn diagrams before, but you have to clearly understand what you're being asked to do with the Venn diagram. And then what's called the general addition rule. Don't necessarily need to know that name, but you need to know there's a very important formula that we'll see here for the first time. So let's look at an example. And we're actually going to use this example first as a two-way table and talk about probability. Then we're going to take the same information and display it in a Venn diagram because it really could be displayed in either form. All right, so it says students in a college statistics class wanted to find out how common it is for young adults to have their ears pierced. They recorded data on two variables, gender and whether the student had a pierced ear. For all 178 people in the class, the two-way table below displays the data. So there is the data in a two-way table. And I abbreviated yes with Y and no with N and male with M and female with F, just to make the notation simpler. Okay, so now we're going to be asked some simple probability questions, and we're going to start here on the right side and work our way down that way. It says one student is randomly chosen. We're finding some probabilities. So first of all, let's be okay with the notation. When I say P of Y, that's when I pick one student randomly, what's the probability I get someone who said yes, which would be yes, they had their ears pierced. And again, you've been doing this for years. This, I think you can clearly see, would be 103, because that's my total number of yeses, over the grand total, which is 178. Like there's nothing, let's not make the easy questions more difficult than they are. There's no reason to reduce that or make it a percentage unless the question specifically asks for a percent. We can for sure leave it like that. So that's the probability of getting a student who said yes. All right, next question. Says what's P of F? What's the probability if I pick one student randomly that I choose a female? Well, that I think just as straightforwardly would be the total number of females, which is what, 88, out of the grand total, which is 178. So, and I could keep going. So that I think those two are fairly self-explanatory. Now, these next two, it's really important that you understand what they're asking and how to find it in the two-way table. One says probability of Y and F. One says the probability of Y or F. Now, I'm not sure what you've done with set notation, but Y and F could also be written as Y intersect F. That's the same thing. And the overlap, the intersection. And then the one over here on the left, Y or F, that's the union of two sets. So you could see this as Y union F. I find myself always using the words and or the word or, but the notation, you've got to know that, and link these, that those two mean the same thing and those two mean the same thing. All right, so let's look at the and first. That means if I pick one student randomly, what's the probability I pick someone who is both female and has had their ears pierced? Well, that's just, let's see, female and ears pierced. That's, I'm circling in green here, the number. Of all my numbers, that's the only number that is the intersection of the female column and the yes row. So this would in fact be, I don't think this is new to any of you either. This would just be 84 out of 178. So you've got to know that the probability of something and something or something intersect something, I interchangeably use the word at the overlap or the intersection. Still over the grand total. Okay. Now let's talk about the probability of Y. I mean, I'm trying to scroll down here. Can I do that like, there we go. Now let's talk about the probability of Y or F. It says if I pick one student randomly, what's the probability that I pick someone who's either had their ears pierced or is a female? Or it could be both, just either of those. So the important conclusion here, let me erase this circle. Okay. So let me remind you of yesterday. yesterday's video. We talked about two events being mutually exclusive. And two events are mutually exclusive if they can't both happen, or if there is no overlap. I would argue that these two events, yes and female, do have overlap. Like there are some students who are both. So first you've got to recognize that Y and F in this case are not mutually exclusive because they can both happen. So the reason I say that is because let me go back to yesterday. We had a probability. We had a formula that said this. It said if A and B are mutually exclusive, like if two events are mutually exclusive, and again in this example they're not, but if they were, the probability of A or B would just be the probability of A plus the probability of B. If there is no overlap and you want the probability that at least one of them happens, all you would have to do is add the probabilities. That's a very easy rule to use, and it's a very powerful rule. But you've got to realize that in this case, we can't just do that because Y and F, yes and female, are not mutually exclusive. So let's think about this. It would be tempting just to add the two probabilities together. So if we did that, turns out not to be right, but we have to figure out why it's not right and what to do about the fact that it's not right. The probability of yes, how many people said yes? I'll circle here, 103. And what about the female? This is not the right formula yet, so bear with me. The female total is 88. So if I were to write 103 over 178 plus 88 over 1, I'm good. 88 over 178. If I were to add those two totals together, I need it to be clear why that would be wrong. So look at those two totals I added in red. I'm going to get out of the highlighter here. The 103 included those two numbers, 19 and 84. Well, the 88 included 84 and 4. If I add up 19 plus 84 plus 84 plus 4, I need you to recognize that in doing that, I double counted the intersection. That 84 there, if I add 103 and 88, that double counts the intersection. I do not want to double count the intersection. I want to count the intersection. Those 84 people who happen to be the intersection, they do count. Sorry, they do count, but I don't want to count it. I don't want to count it twice. So what you have to do here, and I'm kind of going to finish this formula here, to find the probability of, let me go back to my pen. To find the probability of Y or F, you take the probability of Y, which is 103 out of 178. You add the probability of F, which is 88 over 178, and then you have to subtract the overlap, Y and F. And it's really important that you understand what's going on here. We're not, this is how I remember this, we're not subtracting the overlap to not count it at all. We're subtracting the overlap to not double count it. So in this case, the overlap is what, 84 out of 178? So now, if I just add all of those together, or if I do 103 plus 88 minus 84, I think I get 107 out of 178. Make sure that sounds right. No, that's not. 107. Yeah, 107. Okay, so that's how you find the probability of something or something. Now, I'm going to try not to confuse things. Let's go back to this picture. That formula works great, and I'll formalize that formula in a second. But if you've got a Venn diagram, let me erase some highlightings here. Let's understand how else we could have done this same question. The question still said what's the probability of Y or F, yes or female. We could use the formula, which is take the total probability of yes plus the total probability of female, and then subtract the overlap so as not to double count it. We did that We got the right answer, which is 107 and 178. Understand that if you're given a Venn diagram, which you won't always be given, I'm sorry, if you're given a two-way table, and if I want the probability of Y or F, well, I'm looking at, I see that number, I see that number, and I see that number. Like those are the three numbers that are anywhere in either Y or F. If I just add those three numbers together, I do in fact get 107 out of 178. So really that's the same thing. It's knowing what numbers to add together or knowing how to use the formula to find the probability of A or B. So let me now, as promised, formalize the formula, which says this. The general addition rule says to find the probability of A or B. You take the probability of A plus the probability of B minus the overlap, minus the intersection, minus the probability of A and B. Again, that is just so as not to double count it. Now, let me put that right here. I'm just going to type what I just typed a minute ago. If A and B are mutually exclusive, then the probability of A or B was the probability of A plus the probability of B. Like you're allowed to just add them if they're mutually exclusive. I want these two formulas to kind of make sense together, because if they're mutually exclusive, then the overlap, they have no overlaps. And then if they happen to be, so I'll just in here in parentheses, apparently in highlighter, didn't need to do that. I'll remind you that if they're mutually exclusive, then the overlap is zero. A and B would equal zero, which means this piece here that you're subtracting so as not to double count would just be zero anyway. So these two formulas almost look contradictory because one of them has the minus the overlap, one of them doesn't. It's really all the same formula. You've got to know if they're mutually exclusive, there is no overlap, so you can just add the two probabilities. And if there is an overlap, you have to subtract it so as not to double count. Okay. Last thing I want to do in this video is talk about Venn diagrams. And we can take this exact same information and display it in a Venn diagram and still ask the same question. So we're going to take this information, this 178 two-way table, and make a Venn diagram out of it. And you might be asked to create a Venn diagram. You're more likely just to be given a Venn diagram. So let's take these numbers and put in the Venn diagram. So I've got, let's see. So I created kind of the template for Venn diagram. I've got some people that are male, some that are not, some that, yes, have the earpiece, some that are not. There's some overlap there. And then we've got the air and the answer, which is neither. So let's figure out how to put these numbers in the right spot. And if you're ever asked to create a Venn diagram, I think the overlap's easiest. Like this, the intersection, like how many students are both male and yes. Now, I'm not sure why I called this male. On the other one, I called it female. Tell you what, let's just to be consistent. It really could be either way. Let me make this say female, just because that's how we labeled it in the other one. So female and yes. My overlap, we're going to go back and forth to my two-way table. My overlap of female and yes, that was just 84. So that 84 goes right. I'll just draw these in here. That 84 goes right there. There are 84 people who are both female and yes. That's that right there. Now's when a conversation occurs. Now the question goes, what number do I put here? I don't want the total female number there. The total female number would be the entirety of that female circle, which includes that 84. So really, in that square, I need the females who are not the yeses, which in this case is what females not, I think that's just those four. So let me put that 4 here. Let me erase my square and put a 4 here. If I put a 4 here, what does that make the total number of females? That's 88, 84 plus 4. So just be real careful. It's real tempting to think that 88, which is my total females, right? Yes. It's real tempting to put that 88 where I put that 4. Don't do it. The total number of females is 88. Now let's keep going. What about my yeses? My total number of yeses total is 103. But that's in two pieces, 84 who are female and 19 who are not female. I've got the 84 who are female, so there's the other 19 that are not female. Now there are still some students who are neither female nor yes. Which one is those? That's the 71, I guess, that are neither female nor yes. That's going to go out here in that other circle. So you'll notice that the four numbers I put in that Venn diagram are the same four numbers from this two-way table, excluding the totals, but the four actual numbers, 1984, 17, and 4. I'm sorry, 71 and 4. Those four numbers still show up in the Venn diagram. Okay. So now from this Venn diagram, I can ask the same kinds of questions. Let me tell you what, I'll change up the questions here just to make it a little less repetitive. Let me make this smaller here. So let's talk about if I pick one student, what's the probability? Let's go with the probability of male. How would I figure that out from this Venn diagram? Well, first of all, I guess I would need the grand total of these numbers. So you would have to add up all the numbers. Those numbers do add up to 178. Let's remember the total is 178. So which numbers are males here? We got to know kind of which numbers to add up here. I would argue that that number is not female and that number is not female. Does that make sense as the ones that are not female? And if I add those up, what do I get? Do I get 90 that are male, which in this case just means not female? So if I go back to, since I happen to have this as a two-way table, my total male better be 90, and it is. My total male is 90, so that works. So my probability of male would just be, 90 out of 178. Oh, let me get a pen here. Not a highlighter. This is 90 out of 178. Let me remind you that I can write this as the probability of female complement. Remember, that means the probability of not female. Same thing. That would be 90 out of 178. Okay, next one. What if I want the probability of, let's go female or yes? Now, we did this already earlier. Can I erase my highlighting there without erasing my numbers? I don't think I can. Unfortunately, I'm trying to erase that. That didn't go well, but I'm trying to erase the numbers. Okay. The probability of female or yes. Now remember, don't let the formula confuse you. Female or yes. That means any numbers anywhere in either female or yes, which is in fact that number and that number and that number. You add those together, that's where you get that 107, which we got earlier. So in the Venn diagram, if I had to find the probability of female or yes, I would just add up those three, which is 107. And my answer is, in highlighter apparently, 107 over 178. That's the right answer. Could you have used the formula? Sure you could. I would argue that it might be more difficult because to use the formula, you need the total number of females. That's 84 plus 4. The total number of females is those two, plus the total number of yeses, which is those two, and then you'd have to subtract the overlap so as not to double count it. Again, we already did the math based on the two-way table. So what I'm telling you is this. If you've got a two-way table or a Venn diagram, it might be easier just to identify which numbers to add as opposed to using the formula. But what you'll see is sometimes it just says P of A is this, and P of B is this, and P of A and B. Like if all you have is numbers, then you might have to use the formula. Okay. So I did that kind of quickly. Make sure I'm not forgetting anything at the end here. A and B, A or B, the intersect. I think we are good. So there's the rest of section 5.2. It is two-way tables and Venn diagrams with probability, and then knowing that A union B means A or B, and A intersect B means A and B. And then you've got the general addition rule. And your homework is numbers 49 through 60. The first, I think, 8 are actual questions with several parts. The last 4 are multiple choice questions. Again, I can keep urging you to do this not fast enough, soon enough, So if you have questions, you can shoot me an email. We can figure out. I really want to help you all, but I don't know what you don't know till you tell me. So that's the end of 5.2. Section 5 or chapter 5 only has one more section. It's section 5.3. So it won't be too long. This chapter won't take long. So boy, could there be a test by the end of next week? Maybe, if not the very beginning of the following week. Again, I kind of pick up the pace. So that's all I've got. Have a great, what day is today? Friday. Have a great Friday.